Today we're going to look at how to write the equation of a line in point-slope form when given the slope and point that is on the line, and how to use that information to then go and find the equation of the line in slope-intercept form. So with that, there's two different types of problems. There's one where they just give you the point and the slope, and you're going to plug that information into the point-slope form and calculate your slope-intercept form. And the other is they give you 2 points on the line, and you need to first use your slope formula to find the slope between those 2 points, and then choose one of the points and the slope that you found and plug that into point-slope form. So you'll see those kind of examples as we go along. So to start, the most common form of our linear equations is the slope-intercept form, right? That's the y equals mx plus b form that we had talked about the first day of the unit, where m is your slope and b is the y-intercept, or where the graph crosses the y-axis. So if you're given the slope and y-intercept of a line, you should be able to write the equation in slope-intercept form. So in slope-intercept form, just remember we had y equals mx plus b. In this case, the slope is m, right? So up above we see that our slope is 3, and b is our y-intercept. So here our y-intercept's -6. So we're just going to substitute those values into our equation. So substituting in 3 in place of m, we get y equals 3x, and then plugging in -6 in place of b, we'd wind up with y equals 3x minus 6. So we just took the 3 value, plugged it in place of the m, and the -6, and plugged it in place of our b. So another way we talked about to write an equation is our point-slope form. So this is where we have y minus y1 is equal to slope m times in parentheses x minus x1. And this is where m, once again, is the variable that represents your slope, and x1, y1 is a point on the line. So this is a point that is on the line, and m is your slope. So in the second example, they're asking us to write the equation of a line with a slope of 2 that goes through the point 4, -3. So what I would encourage you to do on problems like these is to label your point. So I'm labeling my point as my x1 and y1 values. So here 4 would be x1, -3 would be y1, and then once again my slope is going to be my m value. So here I have a slope of 2. So plugging that into this y minus y1 equals m parentheses x minus x1 form, y minus, in this case our y1 value is a -3, equals m parentheses x minus our x1 value, so -4. And just realize that here, if you subtract a negative number, that's the same as adding. So instead of having y minus -3, let's write that as y plus 3. So here we have y plus 3 equals, so we were going to plug in our m value there, which was 2, x minus 4. So that is the equation of your line in point-slope form. So here we're just replacing the x1, y1, and m values in that point-slope form to come up with the equation of your line. So now I'm going to let you take a turn and label these points as x1, y1, and go ahead and try to calculate out the equation of that line in point-slope form. So I'll let you pause the video now and go ahead and do that, and I will show you what I got for these answers. So looking at the first equation, you see that labeling x1 and y1. So my x1 value is 2, my y1 value is 9, and my slope is -2. So here I'm just plugging in those values in for x1, y1, and our m in that equation. So I wind up with y minus 9 is equal to -2 parentheses x minus 2 as my point-slope form. And over here on number 2, I'm labeling my point as x1, y1, plugging those values and m into my point-slope form. Realize that when you subtract a negative, that's the same as adding. So here, instead of putting y minus -1, I just put that in as y plus 1, and then equals my slope 4, parentheses x, and same thing here, instead of doing x minus -3, I just did x plus 3. So remember, anytime that you're subtracting a negative value, that value is the same as adding a positive. So remember, in our point slope form, we're subtracting there, but if you subtract a negative, that's the same as addition. So here on the next page, they're going to ask us to come up with the equation of a line given 2 points, but not the slope. So this is where we're going to add one step to the beginning, where we first calculate the slope using our 2 points, and then use that slope that we found in one of our points to plug into that point slope form, just like we did on the previous 2 examples. So here, finding the slope using the slope formula, remember that the slope formula is rise over run, or the change in your y values over the change in your x values, right? So it's important that the order here. So we do y2 minus y1 up top, x2 minus x1 down below. So labeling my 2 points, my first point is going to be negative 1, 4, so that's going to be my x1 and y1 values. My second point is the 5, 8, so that's my x2 and y2 values. So I'd always encourage you to first label your points, and then after you've labeled your points, plug those values into that slope formula. That y2 minus y1 would give us 8 minus 4 up top. And then on the bottom, x2 minus x1, we get 5 minus a negative 1, which would really turn into be 5 plus 1. Next, 8 minus 4 is 4. 5 plus 1 is 6. And then you always want to reduce your slope fraction down to its simplest form. So we notice that both those are even numbers, so we can divide both those by 2 to wind up getting 2 over 3 as our value for the slope. Now we're going to take that value that we have for the slope and one of our points. I'm going to use this first point since I've already labeled it as x1, y1, and I'm going to plug it into that point slope form. So remember, that form was y minus y1 is equal to m parentheses x minus x1. So plugging in the values I have, my y1 value is 4, so I got y minus 4 is equal to, the slope is 2 over 3, so that's the slope that we just found. And in our parentheses, we have our x minus x1. Since our x1 is a negative 1, instead of writing minus negative 1, we're just going to write a plus 1. So now we have that equation in that point slope form. So go ahead and try this with examples 3 and 4. First, calculate your slope using your slope formula, and then plug in the slope and one of your points into the point slope form. So go ahead and do that now. You can pause the video while you do that. So here I've done both of those examples, and notice that I've just used the first point when getting to the point slope form. So here I've just plugged in the first point when I got down to my y minus y1 equals mx minus x1 step. But finding the slope, we should have y2 minus y1 up top over x2 minus x1. Simplifying that down as far as we can. So I got the slope to be 3 for both of those. And then plugging in that slope, which was 3, along with my x1 and y1 values into the point slope form, gave me the equations of each of those lines. So if you need to pause it and kind of check your work, feel free to do that now. But I'm going to go ahead and move on to that next. Just look at the next page. It says if we know the slope and a point, we can use the point slope form first and then rewrite in slope intercept form. So here we're going from that point slope form we've been working with, the y minus y1 equals m parentheses x minus x1 form, and getting to that slope intercept form where that y equals mx plus b form. So here, first we're going to use the slope and our x1, y1 values to plug into the point slope form, right? So that was y minus y1 equals m x minus x1. So here they've given us the slope and the point. So here that point is going to be at 4, negative 3. So I got y plus 3 is equal to 2 parentheses x minus 4. So now that I have it in that slope form, I want to then rewrite it into slope intercept form, right, or the y equals mx plus b form. So here the key is we're just trying to get y by itself on that left side. So I'm going to start by distributing the 2. So I have y plus 3 equals 2x minus 8. And the next step is I want to get y by itself. So to get y by itself, I need to subtract 3 from both sides to cancel out the 3 on the left. So I got y is equal to 2x, and then here negative 8 minus 3 takes me to negative 11. So here I have my equation in that y equals mx plus b form, where I have my slope of 2 and my y-intercept of negative 11. So go ahead and try that with examples 5 and 6. I will do them, and then you can check your work. So if you want to pause the video now, go ahead and try to figure out the slope-intercept form of that line, given the slope and your point. So looking at example 5, I started by just plugging in my slope and x1, y1 values into the point slope form, which got me y minus 9 equals negative 2, parentheses x minus 2. To get into slope-intercept form, first I want to distribute that negative 2. So multiplying it by each of those terms in parentheses got me y minus 9 is equal to negative 2x plus 4. And then lastly, I want to get the y by itself. So in order to cancel out minus 9, I would need to add 9 to both sides of my equation. And that gets me my slope-intercept form of that line, y equals negative 2x plus 13. Same thing over here on number 6. I plugged in my point. The only difference here is anytime you subtract a negative, that ends up being like adding the positive. So instead of doing y minus negative 1, I have y plus 1 on the left side. It's equal to 4 parentheses. And then once again, instead of doing x minus negative 3, instead of doing minus a negative number, I'm just going to do plus the positive number. So x plus 3. Next step still the same. We want to distribute the 4. So taking the 4 times x and the 4 times 3 gets me 4x plus 12 on the right side of my equation. And then to get y by itself, we're just subtracting 1 to get y equals 4x plus 11. So now we're just going to continue to take it one step further. So with this step, they've just given you 2 points. So they're asking you to first define the slope, then use the slope of one of your points to eventually find the slope-intercept form of the line, or the y equals mx plus b form of the line. So looking at our 2 points, plugging that into our slope formula, which is y2 minus y1 over x2 minus x1, we get 8 minus 4 over 5 minus 3. So 8 minus 4 is 4, 5 minus 3 is 2, 4 divided by 2 ends up being 2. So here we found our slope to be positive 2. So that was just using these x1, y1, x2, and y2 values from our 2 points. Now I'm going to choose one of my points and my slope to plug into my point slope form. So that's the y minus y1 form equals m parentheses x minus x1. So plugging that in, using my information, I would get y minus 4 is equal to 2 parentheses x minus 3. And then we want to go ahead and distribute and get y by itself. So distributing, I get y minus 4 is equal to 2x minus 6. And lastly, to get y by itself, we're adding 4 to both sides. So I get y is equal to 2x minus 2. And now I've arrived at that y equals mx plus b, or that slope-intercept form. So go ahead and try those last 2 examples, number 7 and number 8. So I'll let you try it on your own, and then I'll kind of put up my work so that you can kind of compare. So go ahead and pause the video now and try to first calculate the slope using your slope formula. Plug in the slope in one of your points into the point slope form, and then distributing and getting y by itself to get the equation into that slope-intercept form. So there is what I got on those 2 examples, number 7 and number 8. First, you want to find your slope. And then once you find your slope, plug in that slope and the information from one of your points into your point slope form. You can then distribute and use your inverse operations to get y by itself and get that equation in that y equals mx plus b form. So make sure you take a look at the Delta math assignment that goes along with writing out your linear equations. And then go ahead and do the homework assignment on Canvas, and don't forget to do the check as well to receive points for your homework. If you have any questions, feel free to send me an email, send me a message on Canvas, and I will get back to you as soon as possible. Thanks.